And welcome to part 2 of the new features for grid infrastructure in 19C. And the first slide we're going to look at is to do with TLS cipher support using CRS-ETL. Now, grid infrastructure uses its own library called Gypsy, that's Grid Inter-Process Communication Library, for all intra and inter-node communications. Now, Gypsy makes use of a number of pre-compiled ciphers to add security to that communication. Now, over time, some of those ciphers may be compromised and we don't want Gypsy to use them. So we now have support in CRS-ETL to add ciphers to disabled lists to make sure that Gypsy doesn't actually use those. So Oracle Clusterware 19C extends CRS-ETL to disable a given cipher suite and stores disabled cipher suite details in Oracle Local Registry and also the Oracle Cluster Registry, so OLR and OCR. This ensures that the cipher suites included on the disabled list are not used to negotiate the transport layer security by Gypsy. To obtain a list of available cipher suites, well, we have CRS-ETL get cluster and transport layer security cipher suites, TLS cipher suite. To add a cipher suite to disabled list, which essentially makes it disabled, we set cluster disabled TLS cipher suite, add, and the name of the suite that you want to disable. You can in future remove it from disabled list as well by using the delete option inside that command. Re-support of direct file placement for OCR and voting disks. In Oracle Grid Infrastructure 12.2, Oracle announced it would no longer support the placement of the OCR and the voting disks files directly on shared file systems. Oracle changed their mind though, and starting from Grid Infrastructure 19.2, the D-support for direct OCR and voting disk file placement on shared file systems is rescinded, but only for Oracle standalone clusters. If you remember, in recent editions of Oracle Grid Infrastructure, we introduced the concept of Oracle Domain Service Clusters, where we have one central cluster which provides a lot of services for other clusters in that domain. Domain service clusters still need to place the OCR and voting files in ASM disks, but if you're using a standalone cluster, you can place them on shared file systems once again. Also a change, in 12.1, Oracle introduced the Grid Infrastructure Management Repository. And in 12.1, it was optional whether we wanted to install that repository or not. In 12.1.02, though, it became compulsory to install it in all grid infrastructure installations. Starting with Oracle Grid Infrastructure 19C, though, the Grid Infrastructure Management Repository is optional for new installations of the Oracle, if you're using an Oracle standalone cluster. If you're using the Domain Services cluster, you still need to install the GIMR. Having this optional installation, though, allows for more flexible storage space management and also faster deployment. Creating and populating the GIMR could add a considerable amount of time to your installation. So it's particularly useful if you're doing installation of test and development systems. It reduces the time it takes because you often create many of these on a rapid basis, and also saves on the disk space. Oracle Domain Cluster Services clusters still require the GMR as a service component because it is capturing a lot of information from in the entire Domain Services cluster. And some more de-supported and deprecated features for 19C. Leaf nodes are no longer supported in the Flex cluster architecture in Oracle Grid Infrastructure 19C. In Grid Infrastructure 19C and later releases, all nodes in the Flex cluster function as hub nodes. The capabilities offered by leaf nodes in the original installation of the Flex cluster architecture can easily now be serviced by hub nodes. The add node script, which was traditionally used to add a new node into your cluster, is deprecated in Oracle Grid Infrastructure 19C. The functionality of adding nodes to the cluster is available in the new installation wizard. That's the grid setup.sh, which was first introduced in 12CR2. Similarly, the clone.pl script is also deprecated in 19C. ClonePL used to clone your Oracle home to allow you to provision or install it to a new node, a new machine. Now that we're using image-based installations from 12CR2 onwards, the need for the ClonePL script is no longer there. We can use grid-setup.sh to create our own images, and we can use grid-setup.sh to actually install from an image as well. So the functionality of installing a gold image is now available in the standard installation wizard. A couple of quiz questions to finish this lesson. The Oracle Grid Infrastructure Installation Wizard grid-setup.sh now enables you to perform a dry run mode upgrade to check system's readiness for upgrade. Is this true or false? This is true. And which of the following statements regarding zero-downtime grid infrastructure patching are true? Zero-downtime grid infrastructure patching enables patching of grid infrastructure without interrupting database operations. Yes, that's true, because we don't have to shut down the database services. Patches are applied out of place and in a rolling fashion, with one node being patched at a time while the database instances on this node remain operational. Yes, that's true. Increases database availability by enabling you to perform a rolling patch of grid infrastructure without interrupting database operations in the node that you are patching. Yes, that's also true. And to enable zero downtime grid infrastructure patching, use the rhpctl move gi home command. Yes, but it needs a particular flag to say that we want to do this in a zero downtime patching environment. So they're all true. And for a summary of this lesson, in this lesson you should have learned how to describe the benefits of dry run validation of Clusterware upgrade, list the features of fleet patching and provisioning, describe the functionality of CRSCTL TLS cipher support, and explain in what situations the optional install for the Grid Infrastructure Management repository might be beneficial for you. Right, and welcome to lesson 1 of the new features for high availability in 19C, and we're going to concentrate on this in this lesson on grid infrastructure. So what's new in grid infrastructure? So objectives: after completing this lesson, you should be able to describe the benefits of dry run validation of Clusterware upgrades, list the features of fleet patching and provisioning, describe the functionality of the CRSCTL TLS cipher support, and explain in what situations the optional install of the Grid Infrastructure Management repository might be beneficial for you. But let's first of all look at the dry run validation of Clusterware upgrades. Now, no matter how often, how much you prepare, how much you read the fine print, quite often when you're trying to do an upgrade or even an install, you've missed something and something goes wrong. Starting from 19C, the Oracle Grid Infrastructure Installation Wizard, or grid-setup.sh, which was introduced in 12R2, now enables you to perform a dry run mode upgrade to check the system's readiness for the upgrade. So you go through all the steps you would for the upgrade, but you have this dry run for upgrade flag set, which means it doesn't actually do the upgrade, it just does all the checks for you. So the dry run upgrade mode, the wizard performs all the readiness checks that it performs in an actual upgrade, allowing you to verify if the system is ready for upgrade. So the things it's checking, well, is the network configuration correct? Is the storage configuration correct? Have you got the right software levels? Have you got the right patches? Does all those checks for you and then reports back into a log file if it's found any problems. So to perform the Oracle Grid Infrastructure dry run upgrade, first of all, you install the software as well. You prepare the Oracle home, I should really say now. Create a new grid home with the necessary user group permissions, extract the Oracle Grid Infrastructure 19C gold image, and then start the installer with the dry run for upgrade flag. The installer will write the system configuration or any system configuration issues or errors into the log file, which is called grid setup actions timestamp.log, and you can read that through and then take any actions you think are necessary. So in this case, the grid setup.sh is sitting, well, the grid home is U01 app 19 grid, And here we're running grid setup.sh with this new flag set. So in a bit more detail, if you're not familiar with installing grid infrastructure since 12CR2, we introduced the idea of image-based installations in 12CR2. So as the grid user, you extract the contents of the grid infrastructure image into the grid home. So you make a directory, you change the permissions on, or set the permissions on the directory to be the owner of the software, so grid and O install in this case. Change into that directory, and you should have previously have downloaded your grid Oracle home image, which is a zip file. And here we're unzipping from wherever we've located it into the current directory. The -Q is quiet, which means don't send so many messages to the screen. Once it is unzipped, you can then run the grid setup script, which is starts the installation wizard. But as we said before, this time it has a dry run for upgrade flag set on it. So it's not actually going to do the upgrade, it's just going to go through all the checks and some of the motions it normally does. Select the upgrade Oracle Grid Infrastructure option to perform the dry run upgrade for Oracle Grid Infrastructure. That's Clusterware and ASM. And on the node selection page, select all your nodes. Select all the installation options as prompted, just as if you were going to do the upgrade. Oracle recommends that you configure the root scripts automation so that the root upgrade.sh script can also be run automatically. Once all the checks have been done, check the grid setup actions log for errors. Fix any errors, report it in the logs as you see fit. Exit the install on the finish page, and then you can relaunch it without any flag to start an actual upgrade, or you can relaunch it with that flag again, the perform dry run upgrade flag, to make sure that all the problems have been fixed. And then launch the installer to do your actual upgrade. Now, fleet patching and provisioning. Now, fleet patching and provisioning is the new name for rapid home provisioning, or RHP. Now, RHP was introduced in 12CR1, but there wasn't a lot of fanfare about it. A lot of people have missed it. It's becoming a very important package, particularly in the grid infrastructure area. How it works is that, well, the original functionality of it is part of grid infrastructure, and you can have a rapid home provisioning server which contained many different images of Oracle homes. And using the rapid home provisioning server, you could provision or copy those Oracle homes to where they were needed. So if you had a large cluster and different levels of software running on different nodes in the cluster, you could provision or push out the correct Oracle home from the central server. In 12CR2, they also introduced the idea of a rapid home provisioning client, and this client could pull the software from the server to the local machine. Even more recently than that, in 18C, they introduced the idea of using the commands locally. So no longer do you actually need the server or the client. You can actually store the Oracle home images on a local file system and install from there. What do I mean by install? Well, if you use RHP or fleet patching and provisioning, the tool is actually RHP CTL to do your installs, your upgrades and your patching. It's one command or one automaton, as they call it, that will do most of the work for you. So if you are upgrading or patching or at least changing to a new Oracle home, which has been patched, or it might actually be a new release, rather than multiple steps that you would have to go through, including things like copying over the listener.oro files, the TNS names.oro files, or even running the SQL scripts inside the database. Instead of all those steps, RHP CTL will actually do most of those steps for you. So it streamlines the whole operation. As we're going to look in the next few pages, there's a lot more functionality that RHP allows us to do as well. So, starting with Oracle Grid Infrastructure 19C, the feature formerly known as Rapid Home Provisioning is now Fleet Patching and Provisioning, FPP. The command is still RHP CTL though. Fleet Patching and Provisioning enables you to install clusters and provision, patch and scale and upgrade Oracle Grid Infrastructure, Oracle Restart, and Oracle database homes, both in a standalone environment and in a cluster environment. It supports Oracle homes going back to 11.2 and up to the most current release, 19C. So, some of the functionality that I should call it fleet patching provisioning gives us in 19C is a zero downtime grid infrastructure patching. Now, grid infrastructure is normally patched in a rolling fashion. So let's say you've got 3 nodes, you stop a lot of the software on the first node, you patch grid infrastructure, you restart the software or relocate the services back to that node, and then you go on to node 2, relocate the software, relocate the services, shut things down, patch, and then go on to node 3. Now, that does affect performance, it does affect availability. All right, not as much as having to shut absolutely everything down while we're doing the patching, but it does affect some of our performance and availability because you're shutting down the Oracle database instances on the node that you are patching. If you are able to use RHP-CTL, you can actually patch without having to shut down the database instances, the services. So zero downtime grid infrastructure patching enables patching of grid infrastructure without interrupting the database operations. Patches are applied out of place and in a rolling fashion, with one node being patched at a time while the database instances on this node remain operational. This increases the database availability by enabling you to perform a rolling patch of grid infrastructure without interrupting the database operations on the node you are patching. To enable the zero downtime grid infrastructure patching, you use the RHP-CTL move grid infrastructure home or GI home command. You need this flag to say you want to do it 0 time. Now that's not the complete command. The rest of the command will actually say what is your current Oracle home or grid home and where is the new Oracle home that you are going to swap over to. Because fleet provisioning and patching works on the idea that you have multiple Oracle homes that you're moving from one to the other. So in a case of patching, you will have created a new Oracle home with the patches there, and you are moving your current software level, you are moving your current software to move to the new grid infrastructure home. So you have the homes there, the older one and the new one, and you swap everything over to the new one. Some more functionality to do with grid infrastructure upgrades. We have automatic transaction draining for grid infrastructure upgrades as well. So if you're using a more traditional rolling patching technique, you can now allow all the transactions to drain from the Oracle services before you shut them down or fail them over. So automated transaction draining for grid infrastructure upgrades provides automatic draining of transactions against the database instances, one node at a time, according to the database service configuration. There are options on the services that say how long you are prepared to wait for the drain to take place, drain timeout. The transaction draining is an integral part of the database service design and are now automatically integrated into the application of rolling Oracle grid infrastructure patches. This transaction draining was previously available for database upgrades, but we're now incorporating it into the grid infrastructure patches and upgrades as well. Automated and coordinated draining of database transactions during the rolling patches using the fleet patching and provisioning reduces the impact of the patching operations. And once the user transactions have been drained, patching operations for a particular node in the cluster can be completed, after which the instance and services will be restarted locally. And then when new connections are established, the connections prior to the patching operation roll onto the next node in the cluster. Automated PDB patching and relocation. As mentioned before, if you're using fleet patching provisioning for patching or installations or upgrades, it works on the basis of having a new Oracle home that has been patched, or it's the new software release that you want to move over to. So you can patch individual pluggable databases in a consolidated Oracle multi-tenant environment by using the same technique. You can have a new Oracle home, which is running a container database, which is running on the new software release or the new patch software. And then you can use the RHPCTL commands to relocate a PDB from the current CDB over to the new CDB. If this is on a different software release, a different patch level, then the PDB will be patched while you are doing this. This enables bug fixes to be patched only in specific pluggable databases rather than across the entire container database. Fine-grained single-instance pluggable database patching reduces the possible risks incurred in a widespread adoption of changes. So essentially you can patch your PDBs one at a time or a collection at a time rather than releasing the patch into all the PDs at the same time. And if you hit a problem, there's a lot of users affected by doing that. So the command to do this will relocate your PDBs, or the RHP move PDB database command. It moves one or more pluggable databases from a source single instance container database to a destination, which is a single instance container database. So this is not for rack instances, or rack databases. The source and destination single instance container databases can be running from a provisioned database working copy. What we mean by working copy, well, this is an Oracle home which has been provisioned or created using RHPCTL. The working copy can be on the Fleet Patching Provisioning server, a Fleet Patching Provisioning client, or a non-Fleet Patching Provisioning client target. The destination single instance container database can be in a higher patch level, which facilitates a patching of the pluggable database to this higher patch level. And to move a pluggable database from a source single instance container database to a destination single instance container database, well, here we have it, RHPCTL move PDB database. The source CDB is this one. Which PDBs are we moving? We're moving 3 PDBs here, 1, 2, and 3. And the destination CDB is my destination CDB. Now, Oracle Restart patching and upgrade. Now, you'll probably be aware that Oracle Restart was deprecated for a while. It was decided not to continue with it. That deprecation has been reversed now. So Oracle Restart is fully supported once again. Well, it was always fully supported, but it's going to be supported on into the future. Now, because it was deprecated for a while, a lot of the Fleet Patching Provisioning functionality wasn't applied to Oracle Restart. It's now fully applied to Oracle Restart in 19C. So Fleet Patching Provisioning can be used to patch and upgrade Oracle Restart, just like it can for grid infrastructure for a cluster and the database software. Using Fleet Patching Provisioning to patch and upgrade Oracle Restart automates and standardizes a process that are implemented in rack database installations. So we can use the same techniques for grid infrastructure for a cluster, grid infrastructure for a standalone, and for the rack and the database software, both rack and standalone database software. Fleet Patching Provisioning also reduces the operational demands and risks, especially for larger numbers of Oracle Restart deployments. You can move the target of a single node Oracle Restart to an Oracle home that you provision from a gold image that includes any patches. So once again, we're talking about Fleet Patching Provisioning, having a number of different Oracle homes which have different patch releases on there. And we upgrade or patch by moving our Oracle Restart installation or database installation onto or into the new Oracle home. Fleet Patching and Oracle Restart patching and upgrading ensures a copy of configuration files such as the listener.aura and the TNS names to the new Oracle home. Use the RHPCTL utility similar to the following. So here RHPCTL add working copy. The working copy or the working installation is the Oracle Restart working copy. You have a response file that will give details of how you want this upgrade to take place, which target node you want it to be sent to. So this is a node in which Oracle Restart is provisioned, and you can either provide a root password or sudo credentials that you need to actually do the upgrade. And that's the end of part 1.